All right, guys, welcome to Factoring Review. Let's begin. We're going to talk about three methods of factoring today. We're going to talk about the GCF method. We're going to talk about the difference of squares method. And we're also going to talk about the box method and how to know when to do each one of these. So how do you know when to do a GCF? Well, technically on every problem you should always check this. Oops, I misspelled always. Every problem you should always check for a GCF. So let me give you guys an example here. 8x to the third minus 12x to the fourth. So what we would do is we would look for something that you could divide out of these two terms that they have in common. Now both 8 and 12 can be divided by 4. Also, they both have at least 3 x's as factors, so I could take out an x cubed. So if I divide 8 by 4, I'm left with 2. And if I divide x cubed by x cubed, I'm left with just 1. But you don't really need to write times 1, so I'll just get rid of it. If you divide 12 by 4, you have 3. If you take x cubed away from x4, then you're left with 1x. And there's our outcome. Okay? So you want to take out the greatest factor that they have in common. All right, let's talk about the difference of squares method. Anytime you have two perfect square numbers being subtracted, you're going to do the difference of squares method. So, for instance, suppose I had 4x squared minus 9. Both of these are perfect squares, and they both are being subtracted from they're being subtracted from each other. So how this method works is you take the square root of the first number, and that's what goes here and here. You take the square root of the second number, and that's what goes last in each set of parentheses, and you make one a plus and one a minus. Okay? So that is the difference of squares method. Finally, the box method. This applies to quadratic form trinomials. So, for instance, ax squared plus bx plus c. These are box method type of questions. All right. These ones are the hardest. They require a lot of guessing and checking. So let me come up with a quick example here. All right. So how this works is basically you make a box, and you put your first term in the top left box. You put your last term in the bottom right box. And then we ask ourselves, what times what makes 8x squared? Now, there's different options there. Just so you know, the x squared will always have to be split up evenly. So we know that one of the x's goes here and the other x goes here. That's just how it has to be. But as far as the numbers go, it could be 4 and 2, or it could be 8 and 1. And it's your pick. I'm going to go ahead and start with 4 and 2. Usually it's the more moderate numbers and not the extreme ones, but it can be the extreme ones. All right, now let's do 15. What makes 15? How about 3 and 5? Now, you may not want to write this down on your paper because I could be wrong. And once again, this is a guess and check, so you might want to wait for me to finish and just watch the process. So I'm going to try 3 and 5 first, and let's see if that works. We know it works if after we get these two terms here, they add up to make the middle. If they don't, then I need to try again. So 4x times 3 is 12x. 5x times 2x is 10x. Now, these two do add up to make positive 22, but I want negative 22. So I got pretty close. Now, anytime you have the right number but the wrong sign, it's an easy fix. all you have to do is make both of these numbers an opposite sign from what they were originally. That changes these, and therefore your outcome becomes opposite as well. So I got lucky, but there's my answer. So the correct factorization for this one then would be 4x minus 5 times 2x minus 3. Now, if you ever don't get it on your first try, you could try swapping the numbers. So like, let's say this didn't work out. You could take the 5 and the negative 3 and switch where they're at. Put the 3 down here and put the 5 up here instead. If that doesn't work, try a whole different set of numbers. Try 15 and 1, and then swap those. If that fails, the only other conclusion we can come to is that this would have to be 8 and 1 instead of 4 and 2. So you have different numbers in different places to put the numbers, and you just keep trying them until you get the combination that works. Okay? There's not really a fast way about it. There's just guessing and checking till you get there. Okay? Now, we have one more topic to discuss before I set you loose. We've talked about the 3 factoring methods, the GCF method, the difference of squares method, and the box method. But when it comes to factoring, sometimes you can factor more than once. How to factor completely. Okay, so no matter what problem it is, you always start by checking for a GCF. If you have one, take it out. If you don't, move on to the next step. The next step is you're either going to do a difference of squares or you're going to do a box method. Okay? Now, after you do the difference of squares or the box method, technically it is possible that you could do another difference of squares. Or after the box method, you could do a difference of squares. You'll never have to do the box method more than once with the type of problems I'm giving you. But basically, you just keep going until you can't factor it anymore. Okay? You're done as soon as there's no GCF, you can't use the box method, and there's no more differences of squares. If you've factored it down to the point where none of those things apply any longer, then you're done, and the problem is completely factored. So I'm going to give you an example of a problem that needs to be factored multiple times. All right, so step 1 is always to look for a GCF first. Do these terms have anything in common? They do. They can all be divided by 3 if you're looking at the coefficients, and they also all have at least one x. So I could take out a 3 and an x. Now, not only that, but also, I don't prefer having a negative in the front. It kind of makes the factoring, if you're going to do the box method, a little bit harder. So I like to take the negative out as well. So I'm going to be dividing all 3 of these now by negative 3x and see what I get left. So if I divide this by negative 3x, the negative 3 and negative 3 makes positive 1. The x to the 5th divided by x leaves me with an x to the 4th power. If I divide this by negative 3x, negative 6 divided by negative 3 is positive 2, and then x divides into x cubed, x squared times. And then finally, negative 3 goes into 9 3 times, and then x goes into x once, leaving me with a 1, but we don't really need to include that 1 there. All right, so that's taken care of. The GCF part is done. But now we have this to look at. Can we factor that anymore? Well, if I wanted to factor it again, the only method I could think of trying would be the box method because it has 3 terms. So we're going to go with a box method approach on that one. Now, I already know it's going to factor, so I'm just going to go ahead and make some space for it. And I'm going to go ahead and put my box in here. The first term is going to be x to the 4th. The last one is going to be negative 3. So what times what makes x to the 4th? Well, remember, you have to split it up evenly. There's only one way that can happen. They both have to be x squared. What makes negative 3? Well, we know one of them has to be 3 and one of them has to be negative. One has to be 3 and one has to be 3. And one of those numbers has to be negative, and it's anybody's guess, but I'm going to go ahead and make the 3 a positive and the 1 a negative. And then we'll go ahead and fill in the rest of the box and see if it works. Do these add up to make the middle number? They sure do. So I have x squared plus 3, and x squared minus 1. Now we might be done or we may not be. Let's see. After you do the box method, it's possible that you could do the difference of squares. So let's see if I can. The GCF is done. This is not a difference of squares for two reasons. One, it's not subtraction. Second of all, you can't really write that as a square root of a nice number. So we're not going to factor that one. But this one is a difference of squares. So we can apply the difference of squares here. How do we do that? We take the square root of that number, put it here and here. Take the square root of that number, put it here and here. You make one a minus and one a plus. And it's possible after you do the difference of squares that you could do the difference of squares again. Now we've already said the GCF is done. This is not a difference of squares. This is not a difference of squares because you can't take the square root of x. And this is not a difference of squares. So we are now officially done. There's no more box, there's no more GCF, there's no more differences of squares. That polynomial has been factored as much as is possible. And so that is what I mean by how to factor a problem completely. Start with a GCF, then you're either going to do a difference of squares or a box method. But regardless of which of those you try, it's possible you do the difference of squares again. And you just keep checking until you can't do either of those three strategies anymore. All right, and that's it. So we'll put that stuff to practice in class. We'll see you then. Bye-bye.